is basically a way for analyzing motion. It's a way to understand how acceleration, velocity, time, displacement, how they all work together. And you might be saying, didn't we already do this? And the answer is kind of. We just didn't use this term. So kinematics is a way to analyze how velocity, acceleration, impact, time, and velocity. Apologize for my poor English. Time and displacement, sorry. Okay, so it's a way to analyze how velocity and acceleration impact time and displacement. Okay, and we've kind of seen that a little bit, but you're going to see in this example that we don't quite have enough at this point to do this effectively. Okay, so here's my example. A car is driving 10 meters per second. It slams on the brakes when it comes, sees the driver with the little girl running into the street chasing a ball. If the acceleration of the car is negative 7 meters per second squared, how far did the car go before it stopped? So we're going to do our knowns and unknowns just like we've been doing. Nothing new and crazy here. So the car is driving 10 meters per second. So that's my initial velocity. It slams on the brake when the driver sees the little girl run into the street. If the acceleration is negative 7 meters per second squared, so A is negative 7, how far did the car go before it stopped? So how far is displacement, and it stops means the final velocity is 0. So we had two equations last unit that we were using. Well, I guess three, but mostly two. So we had V equals D over T, and we had A equals delta V over T. And just as a reminder, delta V means change in velocity, and we found that by doing the final minus the initial. So I'm trying to find displacement. So I need an equation that has D in it. And the only one that has D in it is this one, V equals D over T. So V equals D over T. But you can see already I'm running into a problem here. What velocity do I use? I've got two. I've got 10, and I've got 0. Well, it probably doesn't make sense to do 0, so I'll do 10. That makes a little bit more sense, I suppose. But now I need the time. Okay, well, I need to figure out what time it takes to do this. I don't know what the time is. So I'm thinking here, and I'm like, okay, what can I do to problem solve this? How can I work this out? Well, I need to figure out time. But my acceleration equation has time, and I know A, and I know delta V. Okay, that sounds great. So let's do that. So A equals delta V, so final minus initial, over time. Okay, and just to save us a little bit of time here, rather than working through all the steps, I'll just give you the answer here. So negative 10 divided by negative 7, we're going to multiply the t to both sides. We get a time of 1.43 seconds. Okay, so we would plug that in here for time. And that gives me a displacement of 14.3 meters. Mr. B, I don't know what the issue is. You said that we need new things to do this. I just solved this equation using the exact same stuff we did. Except here's the problem. This is wrong. Because here's the problem. V is an average velocity, and 10 is not the average. And you might be saying to yourself, well, isn't 5 the average then? But maybe, but how do we know for sure? I don't know how long. Am I doing consistent acceleration? There's not a good way to do this. And so why can't we solve the problems with the current equations? So the problem is v equals d over t is an average only, which means if you're not doing a consistent value, this will not work. This only works if you're being consistent, which means no acceleration. So you can only do this if a equals 0. And the acceleration equation can't tell you how far you went, which is a problem. How far you went. Good job. So we need a way to figure out how to deal with these kind of problems. And the way we're going to deal with it is I'm going to give you 3 new equations. So each of these 3 equations I gave a ridiculous name to, and I did that just to help you remember them. These are not like I don't want you to go home and be like, oh man, these physicists made up these weird. No, I literally made up these names. I just made them up. Okay, and it's to help you remember them. Okay, so the first equation we're going to talk about is one called Old Faithful. And the reason it's called Old Faithful is because it's the one that you use most often, and it actually is the acceleration equation. Okay, and it's just rewritten. And the equation looks like this: Vf equals Vi plus At. There you go. Not too bad here. Vf equals Vi plus At. That's it. So far, so good. All right. The next equation is called the Big Chalupa because it's the largest and spiciest of the 3 equations. And it looks like this. D equals VIT plus 1/2 AT squared. Yes, we're getting into some fun things. D equals VIT plus 1/2 AT squared. And the last one is called Ain't Got No Time because it ain't got no time in it. I was running out of creative ideas. Now, what's the point of having weird names? And here's the equation, by the way. V final squared equals V initial squared plus 2AD. So what's the point of having weird names? The point of having weird names is so that if I ask you, what equation did you use to solve, instead of saying Vs squared equals Vi squared plus 2AD, which you're going to forget and you're going to stumble over because it's the first time you're using it, you can just say, I used Ain't Got No Time, and everybody knows what equation you're talking about. So it's an easier way to figure out what equation, and it's an easier way to talk about it, rather than me saying, hey, what equation should I use? And you happen to, it's the D, you can just say it's Big Chalupa, and I know what you're talking about, and everyone else knows what you're talking about. So that's why we set it up that way. So let's go ahead and do our example problem. Okay, we're going to do that example, but this time we're going to use the appropriate equations that we need. So I'm going to write down my knowns and unknowns again. Vi equals 10 meters per second. A equals negative 7 meters per second squared. D equals question mark. And Vf equals 0. Now, you can see why it's so important to do knowns and unknowns. In the last chapter, a lot of you could figure out, okay, I need to multiply, I need to divide, I need to switch it. A lot of you could figure out what you needed to do just based off of the units and the numbers. That is not going to be possible in this one for most of you, if not all of you. So the reason we do knowns and unknowns is it's going to make picking the equation possible. So I need an equation that has all 4 of these things in it. I need an equation that has VI, A, D, and VF. And the way I do it is I just start looking through my equations. So, Old Faithful. Does Old Faithful have VI? Yes, it does. Does Old Faithful have A? Yes, it does. Does Old Faithful have D? No. And so as soon as I see it's missing something, it's out. Okay? Can't be Old Faithful. It's got to be something else. All right, Big Chalupa. Does Big Chalupa have VI? Yes, it does. Does Big Chalupa have A? Yes, it does. Does Big Chalupa have D? Yes, it does. Does Big Chalupa have VF? No, it does not. So Big Chalupa is out. Can't use it. Okay? Hopefully it ain't got no time because I'm out of options after that. VI, does it have that? Yes. A, does it have that? Yes. D, does it have that? Yes. VF, does it have that? Yes. So the equation I'm going to use is ain't got no time. And you can either write that out, you can write out the name, or you can just set it up with the numbers. So the equation I'm using is ain't got no time, and that's VF squared equals VI squared plus 2AD. Again, you need to at least show me the knowns and unknowns, the equation set up, and the answer, same as last unit. So let's go ahead and put the numbers in and see what we get. So 0 squared equals 10 squared plus 2 times A times D. And again, remember, you need to be plugging the things in. Because if you're just thinking, well, I multiply or divide, like if you're just like, oh, it's -7 times 10, that's not going to get you anywhere close because you're forgetting to square the 10. You need to multiply 7 by 2, and you're solving for D, which is on the right side, not on the left side. So these equations are going to be much more difficult to just do automatically in your head. So now I've got it set up. Now I'm ready to solve. So 0 equals 100 plus -14D. I need to get the D by itself. So that means getting plain numbers to the other side. So here's 100 as a plain number. So I'm going to subtract that over. So that gives me -100 equals -14D. And again, be really careful about the signs here. Okay, so now I'm going to get D by itself. I divide both sides by -14. When I do that, I get my final answer. D is 7.14 meters. Notice that that is nowhere close what we got when we did it the other way. We got 14.3. It's actually 7.14. So you really have to be careful that you're using these equations and not the others. Let me point out one last thing that might help you in trying to figure out what's going on. So figure out, first of all, every single one of these equations have A and VI. All three of these equations, Old Faithful, Big Chalupa, Ain't Got No Time, all three of them have A and VI in every single part. However, each of them is missing something. So Old Faithful is missing D. Big Chalupa is missing VF. And Ain't Got No Time is missing time. Now, the reason that might be helpful is some of you might be able to look at this and say, hey, there's no time given. I'm not solving for time and I don't know what it is. So that means I have to use Ain't Got No Time. It's the only equation without T. I can't use T because I don't know what it is. One other thing to point out too is it is possible, some people just like to know what time is. It would be possible to use Big Chalupa to find, or sorry, to use Old Faithful to find time and then use Big Chalupa to find D. That's totally possible. It takes longer. It's 2 steps instead of 1. But you can absolutely do it that way. So let's talk about what I want you to do next.